What happens when we breathe? It's a good question, and today we're going to find out the answer. First, air has to come in from the outside world. When inhaling, the diaphragm contracts and moves down, increasing volume in the thoracic cavity. As volume increases, pressure decreases, and vice versa. So when the diaphragm contracts down, pressure decreases in the thoracic cavity. However, the thoracic cavity wants to maintain equilibrium, which is when the air pressure inside is the same as the atmospheric pressure. So when pressure decreases, air rushes in to restore equilibrium, completing the process called an inhale. This can happen in two ways. The first way is the air comes in from the nares, or the nostril, where capillaries will warm the air, hair filters the air, and mucus moistens the air. Air coming in through the nares will flow through the nasal passage before getting to the pharynx, or the throat. The second way is the air comes in through the mouth and the oral passage. For both, once at the pharynx, the air continues past the epiglottis, the flap that prevents food from entering your airway, and through the larynx, or the voice box, then down the trachea, your windpipe, passing through its ciliated mucous membrane for further filtering. Then the air goes into the lungs through the left and right bronchi, which are large air passages, into the bronchial tree, and finally into the terminal bronchioles and alveoli, or small air sacs at the end of the bronchioles. Once air gets to the alveoli, the oxygen has to get into the bloodstream through a process called external respiration. The oxygen must pass through the alveolar wall and the capillary wall, and to do this it uses diffusion, where the oxygen passively moves from an area of high concentration of oxygen to an area of low concentration to try and keep the concentration gradient even. So, how does the oxygen get to our muscle cells? The oxygen binds weakly to the hemoglobin in our blood, where it can be transported to our muscle cells. Once at the skeletal muscle cells, a process called internal respiration begins, starting with diffusion that occurs again across the capillary walls and into the cells. Oxygen in skeletal muscle cells is necessary in order to create energy for ATP production in a process called cellular respiration, whose waste product is CO2. This brings us to the next phase of our journey, when CO2 diffuses from an area of high concentration of the skeletal muscle cells to the area of low concentration of our blood across the capillary walls. CO2 then reacts with the water in the plasma of our blood to create carbonic acid, which dissociates into bicarbonate and hydrogen ions. This is how CO2 is primarily transported. Once the CO2 has made it back to the pulmonary capillaries, it is released from the blood and diffuses across the capillary and alveolar walls from an area of high concentration to a lower concentration. In order to get the CO2 out of our system, the diaphragm relaxes up to lower the volume in our lungs, which raises the pressure, and in order to maintain the pressure gradient, the carbon dioxide is exhaled. This process is also helped by the elastin in our lung walls, which stretch when we inhale, and then do an elastic recoil to return to their regular size when exhaling, reducing lung volume and encouraging exhalation. That's all great, but how does our body know it needs to breathe? Chemoreceptors work to detect changes in our body. Central chemoreceptors check when the CO2 increases in our blood, as well as when lactic acid is produced. Peripheral chemoreceptors located in the aorta and carotid arteries respond to a decrease in oxygen. Once the chemoreceptors are stimulated, they send a message to the pons and medulla in the brain, which are in charge of the rhythm of respiration, to initiate breathing. And that is what happens when we breathe. Thank you so much for listening, and I'll see you next time. Bye!